In this video, we will look at how to create a density plot in Panopticon. And a density plot is what we have on the left-hand side here. And it has some similarities with a histogram, which we see on the right-hand side here. So the underlying data here is 1000 observations, values in a range on the x-axis here. In the histogram, we have a count for the number of observations that fall into each of these bins that we have created here. While it's in the density plot, we are showing a continuous curve from the lowest observed value to the highest observed value, and we have a y-axis to describe density, which means basically probability that a randomly picked value from all of these would be the value in question on the x-axis. So here, for example, if I point at this point, the value is 100, and we have 107 such observations out of 1000, which makes the probability that a randomly picked value from this sample would be would have the value 100. That is 0.107. So let's take it from the start. If we go here to dashboard 1, we can inspect the data. We have a number of values here. Sample 1, we have sort of sampled 1000 values. And to create the density plot, we need to modify our data set a little bit. So originally we have one column called sample 1. We have added an auto key to be able to split those values up into their individual data rows. If we look at this variant of the data table, which is called data table 1 bins, we have something called a value bin here, which is a calculated column. So we've created a numeric bucket. I've named it value bin. It's based on the source column sample 1, our value column, and I've created equal distance bins and 50 of them, and this is basically what we need to create the histogram. So let's take a look at that. So to create the histogram, I create a bar chart, and I put value bins on items, and I put the count on the y-axis, change the aggregation into sum or count. So count of ones or a sum of ones. And then on the x-axis, I want to remove the minimum interval length. I also want to give these labels some more space so that we can read them without problem. And now we're getting this histogram where we can see that, okay, in the bin from 99.58 to 100.36, we have 107 observations that fall into that bin. So that's all good with the histogram. So now let's create the density plot. For the density plot, we actually need to make a slightly different version of the data table. So I have prepared this data table, which is called ID bins. And what we're doing here is that rather than creating numeric buckets which produce a specific number of equal distance buckets based on the values in the data, we're creating an identity, basically a text value based on each unique value in the data set. And we need to use these ID buckets or value identities as an indexer when we create the continuous curve using the numeric combination graph. So here I'm selecting the numeric combination graph, and the value ID bin is now used on items, and sample the values, the observed values, is what I put on the x-axis. I want to make that a mean, and I have my count column, which by the way is also a calculated column. So in order to be able to make the calculation of density that I'm going to do in a moment, I need a column that contains all ones, so that the sum of a number of observations in that column will reflect the number of observations, and then I can also calculate a percentage share based on that. So that's important. So I'm now putting count on visuals, and here I want to do something which is called percent of total. And if I look on the left axis here, I don't want to use a metric prefix. I want to use formatting from the variable, and I'm going to add some decimals to the format here, 3 decimal digits, I think. And I'm also going to increase the label granularity. Now we're getting somewhere, and if we go back to the visuals, I'm going to tweak some settings here because I want to use smooth line interpolation, and I want to shade the area below the line to emphasize where we actually do have values, observed values in the data set. I could add these dots so we can see that here, for example, we have the value 107 observed a certain number of times. If I add my count column to details and I aggregate that as a sum, we can also get some info here about the fact that there were 6 items out of 1000 that had the value 107. Likewise here we get that information. The typical density plot has probably an appearance which is more like what we get if we set dots to 0 and the line width to just 1, for example. So if I maximize this visualization, this is our final density plot.